Continuing on with factoring, in this video we're going to be factoring trinomials of the form x squared plus bx plus c. So trinomial means there's three terms. The first term is the variable, could be x, could be a different letter, but the variable squared. The middle term has that variable just to the first power with some number in front of it. Could be a positive number, could be a negative number. And then you've got a constant term, just a number by itself on the end. Now, remember how multiplication works when you're multiplying together two binomials with the FOIL method, like x plus 7 times x plus 2. If you FOIL that out, first you have x times x, outside you got x times 2, 2x, inside you got 7 times x, 7x, and last you got 7 times 2, 14. And when you combine the like terms in the middle, you end up with x squared plus 9x plus 14. Notice that 9 in the middle is the 7 and the 2 added together, and the 14 on the end is the 7 and the 2 multiplied together. So if we were going backwards from starting with x squared plus 9x plus 14 and figuring out that that was equal to x plus 7 times x plus 2, we'd be looking for the numbers to go here that add up to 9 and multiply to 14. So we're looking for numbers that add up to the middle coefficient and that multiply to the constant term. And it's usually easier to start with the multiplying part. There's lots of numbers that add up to 9, but not so many possibilities for how to multiply to 14. It's pretty much just 7 times 2 or 14 times 1. So start by thinking, what numbers could multiply together to give me this number on the end? And then out of all the possibilities there, which ones would add up to the numbers in the middle? So if we wanted to factor x squared plus 9x plus 18, what numbers multiply to 18? Could be 9 times 2, could be 6 times 3, could be 18 times 1. Out of all those possibilities, which ones add up to 9? Right, it's the 6 and the 3. So this would factor into x plus 3 times x plus 6, or the other way around, x plus 6 times x plus 3. They're really the same thing because they're the same two factors multiplied together, and when you're multiplying two things together, it doesn't matter which one comes first. So if we want to check this by FOILing it back out, we get x squared plus 6x plus 3x, there's your 9x, plus 18. Let's try this one, x squared minus 14x plus 13. What numbers multiply to 13? Well, you got 13 times 1, and that's almost the only possibility, but you could also have negative 13 times negative 1. Because remember, a negative times a negative comes out positive. And that's the one we want, because we'd have to have a negative 13 and a negative 1 to add up to negative 14 in the middle. So the factoring is x minus 13 times x minus 1. FOIL that out, you get x squared minus 14x plus 13. How about this one? Y squared minus 13y plus 30. We need numbers that multiply to 30 and add up to negative 13. The numbers that multiply to 30, well, there are several possibilities, and they could be either a positive times a positive or a negative times a negative. But can you see which one of these possibilities add up to negative 13? Right, it would be a negative 10 and a negative 3. So we need y minus 10 times y minus 3. Always check by multiplying it out. Y squared minus 3y minus 10y, so there's your minus 13y, plus 30. Let's try this one, x squared plus 10x minus 11. So we need to come up with numbers that multiply to negative 11. And if we want numbers to multiply up to something negative, one of them has to be positive and one of them has to be negative. And they have to add up to positive 10. So let's see, we can't just have an 11 times a 1. Those are the right absolute values, but remember, one of them has to be positive and one of them has to be negative. So we could have a negative 11 and a positive 1, or a positive 11 and a negative 1, and which of those adds up to positive 10? Yeah, it's the one with the bigger positive, the positive 11 and the negative 1. So it's x plus 11 times x minus 1. If you FOIL that out, you get x squared minus 1x plus 11x, so there's your plus 10x, minus 11. What about x squared minus 5x minus 14? We need numbers that multiply to negative 14, so one of them is going to be positive and one of them is going to be negative, and that add up to negative 5. That would be x minus 7 times x plus 2. How about this one? 3u plus u squared minus... Wait a minute. Something weird's going on here. We've got a u squared in the middle, so this isn't arranged the way those others were. Let's fix that. Let's just rearrange these so that the part that's squared is in front. U squared plus 3u minus 10. Okay, that's better. Now we need to think of numbers that multiply to negative 10 and that add to positive 3. So how about a 5 and a negative 2? Okay, so this factors into u plus 5 times u minus 2. Notice they started with u because that's our variable. These have to multiply to give us u squared. So when we FOIL this back out, u times u is u squared. Outside we get minus 2u. Inside we get plus 5u, so that adds up to plus 3u. And then last we get minus 10. Try this one, n squared minus n minus 30. We need numbers that multiply to negative 30 and add up to negative 1. So that would be a minus 6 and a plus 5. So n minus 6 times n plus 5 gives us n squared plus 5n minus 6n, so that's minus n, minus 30. How about this one? 2x cubed minus 6x squared minus 20x. Okay, there's more going on here than in the last few examples. This does not start with just an x squared or whatever squared. What we have here is, okay, remember the last section about factoring out the greatest common factor? Let's do that. What's the greatest common factor of all of these terms? Well, the numbers all are divisible by 2, and when you look at the variable parts, they all have at least one x in them. So the greatest common factor would be 2x. And if we pull that out, factor out that greatest common factor, we have 2x times x squared minus 3x minus 10. And now look at that part inside the parentheses, that x squared minus 3x minus 10. Can we factor that the way we've been doing these other examples? Well, yeah, we can. We're looking for numbers that multiply to negative 10 and add up to negative 3. So that would be a minus 5 and a plus 2. So we still have the 2x out here. It didn't go away. It's still hanging around, waiting for us to do what we're going to do, times x minus 5 times x plus 2. Now, what if we had almost the same thing, but with a plus here? 2x cubed minus 6x squared plus 20x. We could still start by looking for a greatest common factor, which would still be 2x. We could still pull that out, 2x times x squared plus 3x plus 10. But if we're going to go any further with that, we would need numbers that multiply to positive 10, which means they're either both positive or they're both negative, like a 10 and a 1 or a 5 and a 2. But they would have to add up to negative 3, and that's not possible. The numbers that multiply to positive 10 have to be either a 10 and a 1 or a 5 and a 2 or a negative 10 and a negative 1 or a negative 5 and a negative 2. None of those add up to negative 3. So that means that this part inside the parentheses cannot be factored. So we were able to do some factoring. We pulled out the greatest common factor, but then we couldn't factor any further. We can't break it down like this. So our final answer is what we have in the middle, the 2x times x squared minus 3x plus 10. That's factored as far as it can go. And now what about this? X squared plus 4x plus 11. Is there a common factor we can pull out? Well, not really. There's no greatest common factor other than just 1. And if you wanted to be a smart aleck, you could write, oh, this is 1 times x squared plus 4x plus 11, but that doesn't really help us. And if we were going to pull this apart into those two binomials, we'd need numbers that multiply to 11 and add up to 4. But the only numbers that multiply to 11 would just be 11 times 1, or negative 11 times negative 1. And that's not going to add up to 4, so we're kind of stuck. This can't be factored. And that happens sometimes. If you just meet a polynomial walking down the street, there's a reasonable chance that it can't be factored. Some polynomials are factorable, some aren't. The only way to know for sure that it can't be factored is to look at all the possibilities, and if none of them work out, then it can't be factored.